Hello. Okay, now it's time for our next presentation, Identity Theft, Developers are Key. And this presentation is filmed, so we got a mic over here for questions later on. But please welcome Brian Vermeer.
Your identity is probably the most precious thing you have because it describes who you are and what you do. Your identity simply defines you. For a minute or two, just take into account that somebody would steal your identity and do all sorts of things with it and actually get away with it. In my book, that would be pretty terrifying. If you look at cybercrime, identity theft is probably the most concerning part of cybercrime because once you are a victim of it, it's very hard to get rid of the consequences. And that's why we're here. We as developers play a key role in that because people using our software trust us, they count on us, and we write the code. We create the layer of protection on it. So we can say, are we part of the solution to make cybercrime less evil, or are we actually part of the problem? Well, in this talk, I will show you some things to make this world a tiny little bit better. We cannot prevent it at all, but as we want to be, we can be a little superhero. Talking about identity. Hi, I'm Brian. I work for a small company, Blue for IT, in the Netherlands. We work consultancy-based for other companies on mainly Java projects. I'm a software engineer. I'm a developer. By far, I am not a security expert. I'm just trying to share my thoughts and share the things I've seen over the last few years and try to convince you that it's pretty important. Well, some useless facts about me. I come from a town, we go quite fast there. I come from a small town called Breda. It's in the southern part of Holland. Nobody have ever heard of it, but it's awesome. I nowadays work for a bank, a large bank in Holland, Rabobank. Perhaps you know it, perhaps not. It's a bank. We do something with money, mortgages, and that kind of stuff. And you can imagine the data we have over there is pretty important. I drive a motorcycle, which makes me think I'm kind of cool. I'm a really big fan of the New England Patriots. That's perhaps my face is still down because of the Super Bowl, and we won it, and lots of beers, you know. Please, just look through it. I do Taekwondo, and I'm a military reserve. Well, that's enough useless facts about me. Let's get serious. Let's get into cybercrime. If you think that cybercrime is committed by lone wolves, by, say, the 13-year-old kid on his attic trying to be the most awesome script kiddie, please think again. Because if you look at the studies, these days, 80% of all cybercrime is committed by organized crime organizations. And as we know from other types of crime, organized crime is perhaps the most difficult part to get rid of. Why? Because they're organized. They simply work as a business. They hire experts. They're a big group. Perhaps they don't know each other, but they're all experts. And we do the same thing in business, but we try to make business value. We try to develop features. Their job is to infiltrate. And why is this important? Because if you look at other organized crime, like, say, drug trafficking, for drug trafficking, you actually need to do something. You need to carry something. You need to take something with you. And our system, say in Europe, in the US, whatever, is in place for that. And we know how to get rid of it, or we know how to deal with it. We got customs, border patrol, police, whatever. But if we look at cybercrime, we're not ready. The risks are pretty low. I mean, if you do something, you don't need anything. You need a computer, you need an internet connection. And it's quite easy to hide yourself. So if you combine that with the fact that there's a lot of money involved, you can imagine that the problem is getting bigger and bigger and bigger every day. And you can understand, if we leave, as developers, if we leave the door wide open, it gets easier every day. Even if we leave the key under the mat, it will get easier for them. So if you look at the money-wise, it's an infographic from IBM, published in, say, 2015, I guess. Correct me if I'm wrong. Are there any IBM people over here who've seen this before? Well, so I can say anything, basically. But you see the amount of money that that costs cybercrime in general on an annual basis. If we look at studies for 2016, I've seen huge amount of numbers in trillions of dollars. I don't know if they're true, but you get the essence that there's a lot of money involved in it. And if the risks are low, money is high, and we leave the door open, well, all studies say that in, say, 2020 or 2022, these amounts were at least double. So we just say that. Can we just say that cybercrime is real? So if we just focus into identity theft, because that's actually the topic, I was wondering, okay, what is identity theft? And if I'm looking for a definition, I go to the one and only site who has all the definitions, Wikipedia. And you know if it's on Wikipedia, it's true. And I'm not kidding. I will read it out loud. Identity theft is the deliberate use of someone else's identity, usually as a method to gain a financial advantage or obtain credit and other benefits in the other person's name, and perhaps to the other person's disadvantage or loss. The person whose identity has been assumed may suffer adverse consequences if they are held responsible for the perpetrator's actions. Well, there are a few things important in this definition. And you probably guessed it, they're in yellow. To give this definition some body, I will tell you a little story. It's actually a Dutch story. It's the story from Kevin Goes. And you can look it up if you can read Dutch. I don't know if there are any Dutch people in here. No, but Google Translate will probably help you. Kevin, 30 years old. It is a story from 2015. He was a journalist from a place called Heerlen. And one day a mail came to his door, and he opened the mail, and there was a collection agency. And they charged him 13,000 euros, would be like 130,000 Swedish krona, if I'm pronouncing it correct, amount, because it's at least a lot of money. And they say he rented a house in a place called Dordrecht. He's never even visited that place. And he forgot to pay his rent. To make this even worse, there was a marijuana farm found in it. Kevin is a journalist, and he thinks, well, I can make a story out of that. Awesome. So he tried to call these collection agencies and tried to explain it, and actually came into contact with the actual owner of the house. And he found out that his phone number, his name, not his phone number, but his name, his date of birth, and his citizen service number, which is a number on your passport, which is quite similar to your social security number in the US, was actually used to rent that house. There was a phone number provided with it, and he called it, and it was actually someone who claimed to be him. Hello, my name is Kevin Goes, but it was not him. Well, he sorted it out, and they believed him. So he thought, end of story. Month after that, same thing. Mail came through his door, and it was a house in Amsterdam. Well, houses in Amsterdam are quite expensive, but the problem was, this time the bill was a bit lower, 3,000 euros. So he thought, well, hey, I get good out of it once. Let's do it again. Just call the people, but this time they didn't believe him. And that's the point where he left, where he felt that he was out of control. He actually had to go to court. Luckily, his sister is a lawyer, and they just dropped the case just before they actually had to go to court. But the problem was that they accused Kevin of all sorts of things. You were sloppy with your passport, so they were saying, because a copy of his passport was provided with the rent of that house. He said, okay, but I still have my passport. What's the problem with that? So we started thinking. He left the passport at a hotel on his holiday. They copied it. His employers have a copy of his passport. And he probably found a copy of his passport in his cloud. He still doesn't know what happened, but somehow they got his passport, a copy of it. And actually, you see Kevin here. This is the real Kevin. He's a Caucasian guy. And this was the passport. I don't want to be rude, but this guy is not Caucasian, right? Actually, the guy altered the passport with another height, but the rest of the info was correct. So you see that identity theft, once you are part of this system or part of, once you are a victim, it's very hard to get rid of the consequences. You need to do a lot of stuff, and you didn't do it. Well, if we take this into perspective, and we look at what data are cybercriminals after, we can actually say all kinds of data. Because, as we say, data is like crude oil. By itself, it's dead, but it comes to life when applying the right kind of science. And actually, if you take the laws of big data into account, and I know where you work, I know where you live, and I can couple that together. I have a bigger profile of you. So all sorts of data that has some identification to a person can be interesting. Any piece of personal information is useful. Email addresses, employers, date of birth. Because the more I know about you, the more I know, the more I can refine you, and the more I can make a definition out of you. It's actually the same thing as Google does now. Only they do it for advertising purposes. But if you take that data and try to make a complete image out of you, I can actually use it to do all sorts of nasty things, and they blame you. Well, it's good for me, but I don't think it's good for you. So if we come back to that, and you can agree or disagree with this guy, but it comes to privacy. Because how many of this data do we already give away? Just take your phone and look how many free apps are on that. How can they be free? How many trackers are on that? What did you give away for that? Say your location data, perhaps your contacts. What do you put on social media? But that counts for everybody, right? And we're developers, we're awesome. So where do we come in? What can we do as developers? First, protect yourself and be aware. Because if we think, whatever, we leave the door open. It's not only about you. Because if they have you, they probably can get to your customers. I mean, who works with data, who works with applications that have data in it that can be traced back to a person or a group of persons? Yeah, me too. I work at a bank. So if they have you and they can get into your system, they probably also get into, say, production databases, because we all do DevOps, right? Or some do. We have elevated privileges. So if they have your system, or they get into your system, they have your laptop or your account, they can do all sorts of things to that data. And that data perhaps is not even interesting, but they sell it, and we mingle it together, and we have some nice big picture of you. How many of you work with real data for local testing? So a copy of production. Quite interesting. So we see that if we do not protect ourselves, we probably can be victim, and our customers are victim too, and that can roll out to be a big disadvantage for our company, right? So protect yourself. So just another show of hands. Who of you guys work on a laptop or a notebook? Awesome. Works out. Where do you leave your notebook? Because it's quite easy to find out where you work, where you live, and do you drive from work to home and you take your laptop with you? Do you leave your laptop in your car when you do grocery shopping or filling your a car with gas? It's quite easy to get your laptop, right? And who of you encrypt their hard disk? Awesome, thank you. Next question. Where do I store my passwords? Well, I was back home, and my director was in his office. He's actually not an IT guy, but just a manager. And I said, what is the Wi-Fi password? I said, just look at the scheme next to my desktop. And there was a piece of paper with all passwords he owned. I hope you don't do that, right? But you have some kind of password manager, perhaps, on your laptop. Who does that? Me too. So I hope your laptop is quite secure, because if once I'm in it, I can probably go further and get to all your passwords. So if I have one password, who uses their password multiple times? You know that there are scripts available that can just take your password and just drop it on Reddit, eBay, Amazon, and just try it in a couple of seconds, right? And if you use it twice, you probably get screwed more times. Just think of the hacks that we recently did at Yahoo, or a few years ago at LinkedIn. Next question. Is my software up to date? And then I mean your operating system, is it up to date? Who says when his Windows or MacBook says, okay, do you want to update now? Say, screw you, I do it tomorrow. And say that again tomorrow, and the day after it again. Who does that? I do sometimes. But you can imagine if they found things on their operating systems that can lead to intrusion. They've tried to fix it because their name depends on it. But if you do not upgrade, well, we have the same thing, actually. Who uses Gmail? Who has two-step verification on it? Good. I love you. Two-step verification, why not? It's not that hard. Just a thing you know and a thing you own. Two-step verification. If I try to connect to my Gmail account or to some other accounts on a strange machine, they say, okay, that's weird. And I have a one-time password popping up on my cell phone that I have to put in. Well, it's better secure than just your password, even if you use your password multiple times. Hey, do you guys use Wi-Fi now? Who uses the Wi-Fi here? Are you sure? No, I'm kidding. I didn't. But what Wi-Fi do I use? And is that Wi-Fi actually secure? Would you do your banking stuff on the Wi-Fi of Starbucks? I wouldn't, but there's so many people who would. Hey, you guys wouldn't fall for this, right? I hope not. Yeah, we all know this. We all know this kind of things. Or it is a woman. That might be a woman from Libya who has too much money. They want to traffic it through your account. You know the drill. Or the Saudi prince, or the prince from Nigeria. We all seen these emails. I hope nobody fell for that. Because, yeah, come on, really? But if you see this one, it's getting quite legit, right? Bank of America logo on it. There's a copyright rule under it, and it sounds kind of legit. Perhaps you wouldn't fall for it, but I have to agree, my mom would fall for that. My grandmother, if she would use a computer, she would actually fall for that. But thank God we're not in America, so Bank of America would be pretty weird in Holland. But I will give you this example. It's an example in Dutch. And why do I use it? Because this is an actual example that happened a few months ago, and I will translate it for you. It's about the bank's iConnect Wi-Fi settings, and it says, Dear Simon, due to maintenance work, your credentials will be reset. To make sure in the future you can use this Wi-Fi, we ask you to update your settings within 48 hours. Please use the following link for that. With kind regards, ITN Infra Support. And I would say, Simon, it's not a real name. I altered the name just not to mock him that much. But Simon had this on his Outlook from the bank. The infra support department actually exists. It was on his Rabobank email address. It was personalized through his first name, and the iConnect sometimes is out of order, so it's a usual problem. And the point was, it was actually in a very stressful situation where deployments went wrong and everybody had to focus on that one, and this one came in. There were a few people who actually clicked on it and had to give in their previous credentials. And the problem with the iConnect Wi-Fi settings is if you want to use, say, the Git repo or the Jenkins server, or actually go to production, you need to go through that Wi-Fi network, or else you cannot go through that. This was a test from the department itself. And you only could see it if you would hover over the link, and it was a link to a malicious, strange domain. But you see, under the right circumstances, if I know enough about you, I can personalize this good enough and send it to you, and you would fall for it. Perhaps you don't, but your silly coworker, perhaps, or your neighbor. So we have to be focused. Let's go to software development, because we talked about you as a person, but let's talk about our software development. For once, if we look at our applications, we probably think it's like this, right? We're awesome, we're strong. We can do this in parallel, just put another tank to it. We can get a beating, and we're still going strong, right? But perhaps it's actually more like this. We're still quite okay, we can move, we're still quite fast. We can still parallelize it, we can still duplicate it, but we're probably not as secure as we think we are. And if we take into account that we just keep doing what we're doing, I hope we will not end up like this. It still moves, it does the job. It's perhaps not that fast, but yeah, well, I just put 14 of these things next to each other and it will do the job, right? But is it secure? Well, I wouldn't leave my notebook in that thing. It's quite an awesome construction, right? Hey, let's go to some things like, first of all, dependencies. Have you ever seen this? Yeah, it's a Maven POM file, and it's actually line 973 to 1027, and these were all dependencies, and this was just a snippet of it. And when I see this, I'm wondering, how, why? How many dependencies do you use? Because most of the times, if you use a dependency or someone put it in the POM, it never gets out. We perhaps refactored the code, but the dependency is still in, or we still use the dependency somewhere deep down below. And actually, we have to ask ourselves, are all these dependencies needed? I mean, why should I use 15 kind of mapping tools to map my XML to POJOs? Why? And you can say, yeah, that's historically growing, but you can see that there's quite a lot of things to maintain then. Because are all these dependencies up to date? I mean, first of all, do we need them? Is it from a legit source? And when it is from a legitimate source, is it up to date? Because if, say, Spring, for example, has found a flaw in his code, in his library, they try to update it. But if you're not updating, then you still have that flaw in the code. Who is still in Java 6? 7? The rest is on 8, I hope, or is there still some Java 5 people in it? So the problem you have to ask yourself is this reliable? Is it reliable at all? Because if we look at, say, the Common Vulnerability and Exposure Database, I've got 2 examples over here. The first example is a Spring problem. It's the Spring Framework 3. I hope nobody uses Spring MVC 3 anymore because there's a cross-site scripting vulnerability in it. And this is actually free available on the internet. Just to look at it, I just typed in Spring, and this came out. The second one is a Java 5 problem, special vulnerabilities. So if these things are on the internet and are freely available, guys with, say, less legitimate businesses know this too, and they make a living out of it. So try to update your stuff. I hope you do. Sometimes I don't as well, but okay. Another problem is we trust too much. You see Docker over here. I love Docker. Really, really. Docker is awesome. But we have to take care of what kind of image do I use? Yeah, just rip an image out of the internet and it works. Awesome. And my business owner says, okay, it works. Cool. Let's throw it into production, because we go into production every week. But is that image as safe as we think it is? Same holds for GitHub. I'm pro open source development, but we need to look into the code that it has the correct amount of side effects and the correct side effects that does not harm your system. Because if we don't, and we just simply blow it in, well, I can make a project of two that, or two for the bank I work for that would be quite nasty. So don't trust blindly. So what do we have to do? We write the code. We have the privileges. We know the inside story. So we cannot be ignorant and overtrusting, right? We agree? I hope so. So we have to make security part of our development process. That's easier said than done, because we, at least I, am normally focused on business value. No, we want this feature, we want that feature. And when do you want to have it? Yesterday. Yeah, that's pretty impossible. Perhaps tomorrow. And when I have it tomorrow, I put it in, they write tests around it. Testers tried it, and it works on production, but is it secure? Because my focus was totally not on security. My focus was on the feature. So there's a mixture in it. But if we look at our development cycles, we do code reviews. Who does code reviews? The rest of you does pair programming? All right. But if you do code reviews, why just not only focus on clean code and fast code and say if that code it can be used in parallel, but why not just also look at secure code? Many of you people would perhaps say, okay, I want to do that, but where do I start? That was the first question when somebody told me this. Okay, I want to do it, but I need a starting point. Ever heard of the Open Web Application Security Project? Who does? Yes. So if you didn't look at this, please just take a tiny look at the Application Security Verification Standard. Well, that's a whole mouthful, but it's a manifesto or just a simple set of rules that can be applied to all sorts of languages. And it says all sorts of things. I just took a snippet out of it. But say that, first of all, verify that session timeout after a specific period of inactivity. But also there was a line on it that if a session is terminated on client side, it has to be invalidated on server side. But if you take all of these rules, which we actually do for software engineering, do not repeat yourself, things and that kind of stuff. Why don't you just take a look at these and try to pick out the things that work for you or are important for your project and try to embed it in your software project, in your development process? We did, and actually it works quite well. Even for pen testers, they know, okay, we have this set of rules we have to comply to. We just test on that. I talked about code reviews. So, little quiz. What's wrong with this? Any ideas? There are multiple things wrong because I wrote the code and that's okay. Sorry? Awesome. There's a second thing wrong because in the first line I used my password and my username encoded. Don't ever use that. But I will come back to that. But SQL injection. Because if my input is this, then my SQL will be like that. And what will happen in this case? There are two answers. Something goes terribly wrong, or it doesn't compile. Who say something goes terribly wrong? Who say it doesn't compile? Awesome, because it doesn't compile, because we actually need to do this. Because my statement would say, you've got a, how do you call these things? You've got a single quote too much, but if I do this, it will work as well. So what is the solution for this problem? And it's quite easy, because I think we all actually do it, but you recognized it. What is the solution for this? Anybody has an idea? Name parameters. Perfect, 100 points. Most people would say prepared statements, but that's just part of the solution. It's query parameterization. So we actually put question marks in there, and with the prepared statement, we make sure that it's set as a string. So actually, we sanitize it. So if we do something nasty on it, it will be inserted as a string, no problem, or not as big as a problem. But this, you see, this is just an easy example, and you can do this in code reviews. If you see this, please go back to the developer or to the intern, print it out, big red cross on it. Please don't. Second time, shoot him in the leg so he can still do the correct work. Third time, get rid of them, please. Next question, or next topic. Password storage. If we had to store a password, any ideas what to do with that? Just blow, come on. Hash it. Hash it, a little bit, but I will come back to that. First of all, the first one is quite easy. Don't store them plain text. And I must say, in the couple of years I worked for different projects, I've seen so many people store their passwords plain text, even inside the code. So we just decompiled it, and we have the password back. Don't store it plain text. Or don't try to store it plain text, because I can imagine that sometimes it's not that easy, but don't store plain text, take it as a rule. Don't limit the password length. Why on earth would I limit somebody's password length? Does anybody have an idea for that? Because I never thought this through, and I thought, why would somebody do that? Nobody? Thank you. So don't limit password length. Don't limit the character size, because we all know the longer the password is, the more different characters there's in. If somebody wants to have a password that is ages long, yeah, have him. And don't use ordinary hash function. That's why I said hashing is half the answer. And why? Because hashing is very quick. If you use an ordinary hash, it's very quick. So if I know that the password has limitations or not, I just brute force it, and I come with some big machines, some GPUs in that. I make a large cluster, and I send it overnight, and I try to brute force it. Your complete database. For a hash, it's made to be quick. So what we used to do, and if you use MD5, for example, I probably can look the hash up for a collision. There's so many websites on it, and so many people who still use these kind of things. So if you go to password protection, use a password policy. Well, that's kind of obvious. Use a cryptographically strong credential-specific salt. Why should I use a salt? First of all, to make sure there's no duplication. Make sure it's unique for every credential. So not a salt for your complete website or your complete app. Generate it specifically for every insertion. A cryptographically strong hash, strong salt, I mean something like 32 bytes or even 64 bytes, depends on how secure it has to be. And please don't depend on hiding the salt or something like that. Make sure it's strong. Use a cryptographic hash algorithm, for example, PBKDF2. Wow. Now, well, crypto hash, one way, of course, but a cryptographic hash has a number of computations on it, and it makes it slow. And everybody will say, I don't want slow software, but for intrusion and for brute forcing, slow is awesome. If it takes a millisecond or a second, that's quite a lot. And if you want to brute force it, if you use the PBKDF2, there are some libraries available from the OWASP website, and you can actually fill in how many iterations it has to do. Well, for a customer, you can put in his password and wait for, say, a second. There's no problem. But for a hacker, it probably is not that nice anymore, and he will perhaps go continue to somebody else's project who didn't do that. An HMAC is key hash mass authentication code. It's actually something to authenticate that it's correct. I will not go into that. If you want to go into that, please look it up at the OWASP website. They've got a better definition of that, but I didn't want to put it on the slide. And design it that it will be compromised one day. So don't make it, leave it in and never touch it again, even if the project is running for years and years and years. Try to keep this up to date as well. I mean, we used to think that MD5 was great, right? Say, a decade ago, 2 decades ago. But it turned out it's not anymore. So we have to upgrade and see what kind of cryptographic hashes or what systems are into place, because scientists try to improve the work, and from the things that happen, they try to improve the theory, and we have to take that into account as well. Last example I will give you. If I see this, you see that we put a string as a comment into the URL, and the output is like this, so it could be that the comment is actually printed right away on the website. The first thing I would do is something like this. What happened, if it's actually not sanitized, and now I give you the solution to this problem. If it's not sanitized, we just had a cross-site scripting injection, and we can do all sorts of things now. Say, stealing your session. Perhaps if you had put in a password or username, we can route it through to another website. You see that all these things, and these are just the 3 examples, are quite easy to see. So we can actually put that into our system, and please do that in your code reviews. And perhaps you have some plugins for that who can do that, but it's quite easy to make it part of your development strategy. So, to summarize, first of all, be aware, because if you're in danger, your customers are in danger. Protect yourself. It's good for you, but it's good for your customers and your users as well. Try to integrate security in your development process, and if you do not know where to start, please start at that website. And there are lots of more websites, but this one is open and has some suggestions for, at least for the most Java projects. So that's it. That's actually the end of the slides I have. I've got about 10 minutes left. This is my Twitter handle. If somebody wants to ask questions or want to contact me later, just go for it. And I promised somebody that I would take a selfie with the crowd, or else they don't believe me. I'm actually speaking. They think I'm sightseeing. So please smile. What? I can get you all on it. Awesome. Thank you so much. Are there any questions? If somebody has a question, there's a microphone. If you do not want to, oh, yeah, come on, tell me. I will repeat the question.
Yeah, okay, so what would you say about the difference in tactics when it comes to these things if I develop something that's mostly going to be used internally in a company versus if it's a public API or something that's used by our clients?
Do you know if I take shoplifting into account, how many of shoplifting accidents happen with their own personnel?
I don't know. A lot?
Very lot. So do you trust your colleagues? Do you trust?
Some of them are in here, so I'm not sure.
Well, so that depends. I would say if it's used publicly, you have to focus on it more, of course. But internally, I mean, I work as a consultant, so that means I'm here for a couple of months, there for a couple of months, and there's so many of us. They do not know if I did it or not, and if there is something wrong, the consequences are already happening, say, weeks or months ago. So I would focus on it in both ways, even if it's used inside your company, or instead of only used on the internet. But of course, the more users you have, the more you have to focus on this, of course. Did I answer that correctly? Any more questions? Yeah.
I'm interested in what you said about dependencies. Right, you need dependencies. You might not understand the code. You might not have time to check the code. How do you think we should track at least?
So the question is that we have to look into dependencies, and you might not understand the code, and you might not have time to check it out. Yeah, I would say check it out as well. Or you can say, for example, there are some libraries available and some software available that look for dependency vulnerabilities. The OWASP has a project for that looks for, I think, on the CVE website if it's already published, so you can use it there. We use it at the bank. I think we use CLR for that looks if the dependencies we use are known to be vulnerable, and try to figure out if the dependency is from a reliable source. That's what I would do. I mean, if you put a dependency in your code that's actually from some company or something you really do not know, I would really check it out first. But if it's, say, a Spring dependency or Hibernate or GPA well, I guess if you take the correct version and you keep that into account, you're pretty safe. So there are, on one hand, there are tools for that will scan that, and you have to maintain and make sure that it is at least a reliable source. Did I answer your question? Any more? Yeah.
How do you find the sub-dependencies that might not be from as reliable source as the main dependency?
So the question is, how do we find out sub-dependencies? I would say actually the same answer, because if it's from a reliable source, it's their problem, but it's their name also hanging on that piece of software. And I can imagine that, say, Spring or something wants to fix their dependencies right away, and if somebody noticed that there is a vulnerability in it, they will try to do that. So I will not decompile and look at every dependency which my dependency is depending on, but actually the same answer as I gave the other guy over there. One more? No? Then I would thank you for your time and have a great JFocus. Thank you.